So let me start from the beginning now. This is our database Focus One. Inside Focus One we have multiple schemas or multiple users, and one of the special schemas is called as a sys, and that sys is this schema is created, and the objects inside that schema are created when a DBA creates a database. The very first step is to create a database. At that time he takes one special step which will create a schema sys and all the objects inside that schema sys, and this is where all the data dictionary objects are stored. Whatever data dictionary objects that we saw, user underscore tables, db underscore this, and maybe those are all views. Those are data dictionary views, and a view is created on a base of a table or set of tables. So those base tables, those views and everything is sitting inside that schema called as sys, and sys is therefore a very, very important schema, and you should not touch that schema. In fact, you should rarely log into the sys schema, because by accident you may drop a table, and if that table is dropped, then you don't know what problems you will create, because you are actually dropping the metadata, the actual information about that database, and that metadata is not just for our benefit, it is for everybody's benefit. Oracle itself is using that information to do certain other things. So don't log into the sys schema unless and until it is really required. You do need to log in as user sys. When I'm using these words, when I say don't log in into sys schema, that means don't log in as user sys. It's one and the same thing. So you will need to log in as user sys when you need to do some special tasks, and those tasks are starting up a database and shutting down the database. We'll see what that startup and shutdown process is, and what is the meaning of startup and shutdown in a different way. But for certain important tasks you do need to log in as user sys, but at that time you need to be very careful. So this is one user. Then there is another user called as system. This is also another user which is created during the database creation process, and this user also has certain not so important tables. Most of the important tables are in the sys schema, not so important tables are in the system schema also. The moment you create a database, there is a documentation from Oracle. It will say that immediately change the password of user sys, immediately change the password of user system. Why? Because the passwords are well known to the entire world. If you don't change those passwords and you make sure that all other passwords are tightly locked, then still that doesn't mean that your database is highly secure. Anybody can log in. The password of system user is manager, system manager, and this is change, CHANGE, change underscore on underscore install. These are the two passwords that are by default given to the system user and to the sys user and the system user. They are known to the entire world. Anybody who has been working in the field of Oracle knows those passwords. So as a fresh DBA, as a new DBA, when you create a database, these two schemas will get created. You should immediately change the password. How do you change the password and all those things, we will see little later. So remember that these two are kind of important schemas. And now when you are creating a database for the first time using the graphical user interface, which is Oracle Universal Installer, it will ask you one question: would you like to create sample schemas for our own understanding and benefits? So there are certain sample schemas. One is called as HR. Okay, and then it will have certain objects. In fact, all the SQL, the things that we have learned so far are with the help of tables inside the HR schema. Employee table, department table, this table, that table. Everything is now created by Oracle, and all those are kind of, so HR is there, SH is there, quite a few different things are there. So it is good for us from the learning point of view. So these are certain schemas that you should remember, this and this. Okay, so that is one thing that I had missed earlier. Let me see what type of schema objects that we had talked about. We had talked about tables, we had talked about indexes, then views, synonyms. Then there is one more thing, yes, called as a database link, LINK. That is also an object. And we are going to talk a lot about database links when we talk about the networking concept. I listed earlier that there was a networking thing, listener thing that we have to understand. And database link is an object which will allow one database, that means Focus 1, to connect to another database called as Focus 2. That is what a database link is. One database connecting to another database. So that is what a database links are. And then obviously programmatic packages that I have seen is is database procedures, functions, triggers. Those are the three things that I had described: procedures, functions, and triggers. Functions, triggers. Now all these things, these are programs which are written in a language called as PLSQL. This is a proprietary language for Oracle. PLSQL is only for Oracle. If you are working in Microsoft technologies, Microsoft SQL Server, they have their own proprietary language called as TSQL, Transact SQL. That is a programming language using which you write procedures, function, triggers in the Microsoft database. Using PLSQL, we can write procedures, functions, triggers for Oracle only. Now, starting from Oracle 8i, Oracle said, yes, PLSQL is a very popular programming language for our database, but we will also introduce another programming language using which you can write procedures, functions, and triggers, and that programming language is Java. So there could be Java Java procedures, Java functions, Java triggers, or there could be PLSQL procedures, PLSQL functions, or PLSQL triggers. Depending on the ease and understanding of the programmer, he would either use PLSQL or Java. My experience is still 95% of the shops in India or even outside India in the US, they are using still PLSQL very heavily to create procedures, functions, and triggers. And there is one more thing called as packages. Packages. Packages is nothing but the collection of functions or procedures. If you have written 3 functions and 2 procedures, all separate programs, and you club them together under one name, that one name can be called as a package. Package is collection of all those things. So Oracle has written so many packages, many packages themselves. They have written those PLSQL programs themselves, and they come with our database, and those packages are again objects inside the sys schema. Those are objects inside the sys schema, and using those packages we usually do a lot of DBA activities. So we as a DBA don't need to know how to write procedures, functions, and triggers and all that stuff. We don't need to learn PLSQL programming, but we do need to understand what a function is, what a procedure is, and what a package is, and then we need to learn how to execute those packages. That is something that we are going to do today, and that is my goal today. We are not going to learn PLSQL programming, but we are going to understand what it is, and we will learn the packages that are there. At least a couple of packages. For example, the most commonly used package by a DBA is called as a DBMS underscore scheduler, DBMS. And we have like one huge big topic and chapter for this one package, DBMS underscore scheduler, in administration too. Using this DBMS scheduler, we are going to learn how to execute a certain program at a specific time. It's like a scheduler, Windows scheduler, Unix scheduler. This is an Oracle scheduler. Using this package named DBMS scheduler, we as a DBA will learn how to execute a certain shell script, how to execute a certain procedure or a function at 2 o'clock in the middle of the night without any human intervention. So even though we don't know, we won't learn how to write PLSQL programs, we should know how to use them. That is what we are going to do. So those database link is a object that I had missed earlier. Now one thing that I would like to mention, all the objects in Oracle, whether it's a table or a view or a sequence or a synonym, they are going to be less than 30 characters, 30 or less than. You cannot create a table which is a huge table with the same name. Then it cannot have certain things, that it cannot start with a number and all that stuff. So there are certain restrictions, but the biggest restriction, remember, is the total number of characters. That is all one thing. Now it also says that certain special characters like exclamation mark and all that, there are certain special characters which are not allowed in the names, and the characters which are allowed in a name. So if you are creating a table, create table, what is going to be the name? That name should contain only underscore, or should contain a dollar, should contain a hash. Any other special characters are not allowed. It is not allowed. In fact, I know that for sure, because that has a special meaning. When we use database link, we are going to use the @. So @ is not allowed. Only these are the special characters that are allowed, and the length restriction is 30. So don't use any of the other characters. Now I think we have gone through this in our SQL class, but still it is kind of part of the DBA class. I'm going to go through the different types of data types. When you create a table, you create columns inside that table. What different data types are going to be there for those columns? Tell me the data types. You guys know it. Data types for the columns of a table. Number is there, yes.
Varchar, varchar2.
Number, varchar. Varchar is actually varchar2. There is no varchar.
By default.
By default, it is varchar2. Char. Long. Okay. Long is the old one. It is not there anymore. It is only for the backward compatibility. So I'm not gonna write long here. Okay. Date. Yeah. Date is there. blob. I would like to discuss about blob. Clob. Anything else? Bfile. So we will talk about differences between those there. Then for each of the character and varchar, there is a n and n also. N character and n varchar. We will talk about them also. And then there is a long and other things. Those are for backward compatibility. There is also something called as timestamp. I would like to keep these things two together. So let us talk about these things. Number is only digits. You can specify the decimals and no decimals, and everything is acceptable over there. So numbers have precisions and scales. Okay, so precision and scale clubbed together. Precision, P and scale, correct? Clubbed together will be the total number of digits before and after the decimal point. So that is something that we have done in our SQL class. So I will not go into the details of that. I would like to talk about the difference between varchar and char. Actually, when I say varchar, I mean varchar2. I'm just used to saying varchar. There is nothing called as varchar in Oracle. It is always varchar2. So what is the difference between a varchar2 and char? The fundamental difference is that how the data is stored inside the database. If you are going to store a string, let us say this is 10 and this is 10. You created a column called as a name with varchar2 10, and you store a word shaker inside that. 1, 2, 3, 4, 5, 6, 7. So 7 characters are there. So how much of space will be taken out of that 10? 7, and plus there is some overhead. It's not exactly 7. There is an overhead over there, and that overhead will tell you actually how much of the data out of that 10 is how much of length out of that 10 contains the data. So that overhead is one more extra number which will tell you 7. Now if you store shaker over here, even though this has 7 characters, it will use all 10 spaces, and therefore even if data is small, because the ability to store is much more bigger, it will utilize the whole ability. So do not use char if your data is going to be of a variable length, and that's why they have var for variable length. So less space is required over here and more space is required over here. Then why have they introduced char? Char should be used only in those situations where you know that the exact length of the column is always going to be 2 characters or 4 characters or 5 characters of all the rows. Example is let us say states. We have Maharashtra and Karnataka and all that stuff. So we have abbreviation of a state. We have MH for Maharashtra, K for Karnataka and all that. All the abbreviation are 2 letters. Okay, 2-letter abbreviations for everything, all the states in India. So we can say that char2 should be state instead of saying varchar2. So that time you know exactly this is there, because if you have 2 here, then there would be an extra overhead also for that varchar. So in that situation, which situation? When you know that the amount of data is exactly going to be of this size, use char. Otherwise use varchar. So that is the fundamental difference there. Now n N is for that globalization business. Globalization basically is when you are trying to store the Chinese and Japanese and all different types of data. Why I mentioned Chinese and Japanese? Because Chinese characters and Japanese characters are characters which require more than 1 byte. English characters, one character is 1 byte. A is 1 byte, B is 1 byte, C is 1 byte. But in Japanese and Chinese and all other languages, one Japanese character will require maybe 4 or 5 multiple bytes to represent one character. And that's why at that time when you are storing that kind of a data, which is very rare in India probably, then you use N varchar or nchar for that multiple kind of a thing, multiple byte characters. So I don't think we have any systems here which are using that, and most of the systems all over the globe. I have not worked on any of the systems which are Japanese or Chinese, because again suddenly what happens in that situation, you have to use different order by clause, different group by clause, because their alphabetical things are different. All those things are different. So this is the difference between char and varchar. Now date and timestamp. When to use date, when to use timestamp. Date is a data type which stores date as well as time. Date as well as time. And timestamp is a data type which will store date as well as a time, but not in the millionth of seconds. It will store it in less frequency there, or less precision, I would say. So date for more precision, timestamp for little less precision. I think I have forgotten, but I think still timestamp will store it in seconds and milliseconds also, but it doesn't have micro and all that seconds. So timestamp could suffice if you want to store date as well as timestamp. And now the next thing is blob and CLOB. Blob is for images or videos or anything which is the binary data. JPEG file, GIF files and all that stuff. If you want to store that into one column of a table, for example, you have an employee table, you have one row for the first employee and last is image column. So in that image column you want to store the entire image which is of size 50 kilobytes. Then that is going to be blob, blob, binary large object. And then CLOB is basically, instead of varchar, you would like to store huge amount of text. And this is used in many of the call centers. When you are designing a system for a call center, they will actually have a note that is typed. Okay, Mr. So-and-so called and he complained about this and he complained about that and so on. And they type a huge 2-page case for that complaint. And that is all text. That is not binary. That is not images. So for that kind of a text to store inside the table, we use CLOB, character lob. So text files, Notepad and VI, they are CLOBs. But Microsoft Word, PDF, all those files or images, those are BLOBs. Because Microsoft Word, even though for us it looks as a text, it is actually binary file. So if you want to store the entire Microsoft Word file, or you want to store the entire Excel file, then you should use blob. And then B file and blob, they are very similar. The fundamental difference though, that the file itself, the binary file itself is stored outside the database and not inside the database. When I mean by outside the database, it means the pointer is stored in that column and the actual file is sitting on the OS, the operating system. That is what the B file is. So these are kind of fundamental data types that you will be going through. Now on the date side, I want to kind of ask one question to everybody. On the date side, let us say we have I have a sequence of statements here. Create table ABC, and inside that ID is number and date of birth is date and name is equal to 2 and 10 and a semicolon and a comma and a semicolon. So I have created a table like this. Now after this I am going to insert into the table. Insert into ABC, values, ID is 10, date of birth is, let us say, cis date, and today's date, let us say today is, what is today's date? 13th of Feb 2011. Okay, so sys date is inserted, and then name is let us say Shekhar, and a semicolon. So this also the thing goes in. I also commit that just to make sure that it is correct. So that is the third command, and the fourth command I execute: select star from ABC where date of birth is equal to sys date. Where date of birth is equal to sys date, what output should I see, or what output will I get?
No rows selected.
No rows selected. And why is that? That is what I want to kind of ask. Why no rows selected? Your answer is correct.
Time also saved.
Because of the time constraint. Because when I entered sys date, I am not just entering the date. I am entering date as well as time. So when this was entered, maybe it was 3 o'clock in the afternoon, 20 minutes and 25 seconds. That is what the time that was inserted. 13th of February 2011, 3 o'clock in the afternoon, 20 minutes and 25 seconds. That was the time, that was the thing that was inserted. Date as well as time. And now when I execute this select statement, what will get compared? It will get compared all the date of births, which is now 3 minutes, I'm going to say 3 o'clock, 20 minutes and 25 seconds. That will get compared with, let us say I execute this command 2 seconds later, and 2 seconds later 3 o'clock, 20 minutes and 27 seconds. So because of that, the 27 and 25 will not match, and you will not get any rows over there. This kind of proves that the date columns will store the time stamp along with the date when the data is stored. Now if I want to now find out today's data entry, what should I write now? That is my next question to you. This will not work. This will not give me any data. Now if I want to see what were the sys dates, what were the date of birth for today, what should I do? That means 13th of February 2011.
Where DOT is greater
Where?
than, 12th of Feb.
Not greater than, so it will give me tomorrow also. Okay, so where, I'm just going to write where clause, where date of birth, you said greater than what? 12th Feb. So it will give me day after tomorrow. So I just want to go for a specific date. Your answer will work. What I would like to do is get rid of the time part. And that is where we have learned the function, where trunk of date of birth is equal to trunk of sys date. Trunk will remove the actual timestamp, and it will just compare the date part of it. That is what the date business is. If I want to compare only this year, so I would say where to_char, so I'm going to convert this to char date of birth, and then I'm going to only say y is equal to same thing, to_char sys date y. So I'm comparing only the year part of it. Same thing on the other side. Okay, so data types is something that we have done. What types of objects that we have also done. And then I'm just going to mention, since it is in your book at this point of time, indexes. Indexes is a type of object, or index is a type of object. Now there are different types of indexes. I'm just going to mention the name of those types. One is the B-tree index, and the other one is a bitmap index. These are the two main types of indexes, and we are going to talk in much more details about the indexes and how it will increase the performance during our administration too, and during our performance tuning kind of a thing. But right now just remember that when we create an index on a table, The purpose of an index, I will just summarize the purpose. The purpose of an index is to increase the performance of our statements, whether it's insert, update, delete, select, whichever statements are there. That is what the purpose of an index is. And which type of index to be created is decided based on the type of data in a specific column. We will see also what are the different types of data are there. It's not the data type, it's like the cardinality of the data. So we'll talk about the cardinality of the data also a little later. But that will decide whether you're going to create a B-tree index or a bitmap index. Now we did not know about the B-tree and the bitmaps and all that stuff. The moment you create an index, by default it is created as a B-tree. And this is the syntax. Create index. Name of the index, let us say ID X1. On, name of the table is employee. And name of the column is name. So this is the syntax for creating an index. And as I said, the purpose of an index is to improve the performance of any select statement that will be writing on the employee table with some specific where clauses. So right now this is the only thing and this is, what type of index is this? This is a B-tree index. If you want to create a bitmap index on the employee table, then you add a word here, bitmap. And what gets created and what is the difference, all that discussion is little later. So this very basic chapter is this chapter number 6 in your book. It is talking about the different types of objects. What are those objects, sequences, synonyms and indexes and all that stuff. Very basic concept of object. And now we will move to the programming objects, which are functions, procedures and triggers and all that stuff. So let me now show you the programming objects. Okay. Okay, I think they have gone through a lot of things. Programming objects. As I said, in PLSQL programming, we have procedures, functions, triggers, and packages. I'm just going to show you a simple procedure now. A very simple procedure. If you come from the programming background, this will be a very piece of cake for you, a very simple thing. If you don't come from the programming background, it will still not be very complicated. So how do you create a procedure? You first go and create a file. Let us say the name of the file is proc1.sql. Okay, the name of the file is proc1.sql. You can create this file in VI if you are on Unix. You can create this file on Windows, in Notepad if you are on Windows. And what are you going to write in this file? So I'm going to write all those things in your file. Create procedure, just like create table. And the name of the procedure, in my case the name of the procedure is proc1. That is the object that I'm creating. It's a PLSQL object. Create procedure proc1 as, that means the code for that procedure is starting from here, and then you type begin and then you type end and a semicolon here and a slash here.
Sir, what is the purpose of the procedure?
Purpose of the procedure, it's a programming unit. That means anything that you would like to maybe do automatically. Now what I'm going to do here in this procedure, I'm going to write a loop. Loop is basically something written inside a loop will get executed automatically. Get executed multiple times. So I'm going to write one insert statement, and I'm going to put that insert statement inside a, now it's kind of cold now. I'm also getting cold. You keep the control with you. Okay. So inside this stored procedure, I'm going to write one simple insert statement, and that insert statement will get executed when I execute the stored procedure, and then I will put that into a loop. So I'm going to say insert into a table. Let us say name of the table is A, and this table must be already created. Insert into A values, let us say 100, and the name is ABCD. This is the table, let us say. And now I will bring this over here, end semicolon slash. So this is the procedure I have created. The name of the procedure is proc1. Inside that, anything written between begin and end is the actual code, source code of that procedure. And I have written one simple insert statement there. I can write an insert, update, delete, select, anything over there. I have written simple insert statement. What is the advantage of doing this thing? First thing, now it is a program now. Okay, in Oracle we call it as a procedure. Now how do you compile this thing? First step is to create. This is step number 1. Second step is to compile. First is to create. Create means just write the code. How do you compile? You go inside SQL Plus and you type the command @ and the name of the file, proc1.sql. This is what you do at the SQL prompt, the @ and the proc1.sql. The moment you do this thing, it will execute this code here and it will say procedure created successfully. Just like table created successfully, you will see a message called as procedure created successfully. So what procedure has been created? The name of the procedure is proc1. From this point onward, this is what we call as a compilation. Okay, this is creation, this is compilation. After the procedure is compiled, then you can execute the procedure. And now I will write the code here because I don't have too much of space. At the SQL prompt, after you have compiled it, you are going to execute it. You execute a procedure like this, exec, that means execute. You can type the whole word execute also. And the name of the procedure, proc1. That's it. Execute and the name of the procedure. The moment you execute it, what happens? Anything that has been written inside the body of the procedure, which is anything between begin and end, in this case, insert statement will get executed and it will do its job. If I write 10 insert statements over here, it will execute those 10 insert statements one after another. If I write delete statements here, if I write insert plus delete, whatever I write between begin and end will get executed the moment I say execute proc1. So this is what a procedure is, PL/SQL procedure. Now I am going to modify this a little bit.
Then that file name in Linux should be in the .sql.
It should be .sql, yeah. The file name is .sql. Not just
Created in OS or what?
that is created in OS. File is always in OS. So open a notepad, open Unix VI, whatever, and create this file in notepad or VI.
We are creating that script file. That is.
This is a script file, yes. This is a script.
You can locate it anywhere.
You can put it anywhere. If you put it under the D drive, then the only difference is going to be SQL at the, you say @d:/ whatever your name of the directory is, let us say dir1, and then backslash the name of the procedure is proc1.sql. You just give the full path. If it is in Unix, you give this kind of path, a different way. This is how you compile it. Compilation will make sure that the procedure has been created successfully. That means at that time the object is created. And once that object is created, we will see the name of that object in user_procedures. Okay, after it is compiled. Now, and this thing. Now I am going to write a simple code called as for I in 1.1000. And then I'm going to type loop, and here I'm going to type end loop and a semicolon. Okay, see what is this? For I in 1.1000 loop, end loop, and between that I have an insert statement. Anything written between the loop and the end loop business will get now executed how many times? 1000 times. And here instead of 100 I'm going to put an I. So what is going to happen now? This insert statement will get executed 1000 times. Every time it will get executed, the value of I will change from 1 to 2 to 3 to 4 to 5 all the way to 1000. Once 1000, so 1000 insert statements will be executed within this just small procedure. One, that is the syntax for PL/SQL. This is how PL/SQL syntax works. 1 dot dot and then 1000. If I say 1000 dot dot 2000, then 1000 dot dot 2000, it means it will execute it again 1000 times. Actually I should say 1001, and the value of I will change from 1001 to 1002 to 1003 to 1004 and all that. So this is what a loop is, and again you compile this thing by typing @ and the name of the file, and then execute it by typing exec and the actual name of the procedure, proc1. So this is what a procedure is. Function is very similar. The only difference between a procedure and a function is that here instead of a word procedure you write function, and the job is also done. There are some very fundamental programmatic differences between a function and a procedure. The PLSQL developer would know when to write a function and when to write a procedure, but syntax is very similar. Very similar. 95% of the syntax is exactly the same.
Is there a semicolon after ABCD?
Yes, so this is like our simple, semicolon. This is, each line will finish with a semicolon. Okay, so this is a for, starts from here, for ends over here, so there is a semicolon for, and within the for there is an insert statement, so there would be also an insert over there. So this is what a procedure is. Now you know how to execute a procedure. Okay, likewise, if I create 10 different procedures and put them into something, one place called as a package, then what happens? I have a package whose name is pkg1, and inside that package I have, let us say, 4 different procedures. Name of the procedure is proc1, the another one is, let us say, proc2, and then the proc3, and so on. So this is what my package is. Package is collection of procedures or functions together. The name of the package is pkg1. Now if I want to execute procedure 2, which is inside package pkg1, here is what I type at the SQL prompt. SQL execute pkg1 dot proc2. Execute. This is what you type if you have created a package like this. Okay, and then very important thing that a DBA should know, that when a procedure is a program, when any program gets executed, many times that program requires certain information. Okay, so for example, if I want to insert a value of shaker, then I need to pass shaker to it. That is a programming passing thing. So here you pass some information there in single quotes, ABCD. And what will happen with this ABCD? The program proc1 will do something with that ABCD. It needs that information maybe, and then it will print it maybe. It will drop that table maybe. It will insert into that table ABCD. So depending on the design of the program, this information is used internally. So this is how you pass the information to the procedure. If you want to pass information, this information passing is called as argument. So the first argument is this, second argument is 10, third argument is sysdate. Maybe depend how many arguments you have to pass. It depends on what the programmer has written. If the programmer has written a procedure proc2 with no input information required, then you don't need to pass any of this stuff. If the programmer has written the proc1 so that it will require 3 pieces of information, whatever those are, you need to know them. And this is what the whole thing is. Why am I telling you this thing? Because we are not going to write any procedures and functions and packages, but we are going to use the packages which are already written by Oracle. So there is a package called as dbms underscore stats. dbms underscore stats. In that package there are many procedures and functions. One of them is gather schema underscore schema underscore stats. Okay, dbms underscore stats. In that there is a procedure called as gather underscore schema underscore stats. Now what does this do? What is the purpose of this gather underscore schema underscore stats? What is the purpose of this package? That is something we are going to learn in detail when we talk about performance tuning. But at that time, I will suddenly say that, okay, there is a package called as DBMS stats, just execute a procedure called as gather schema stats in that package and pass the first argument as the name of the schema. And then it will collect statistics for that schema. So what is the statistics and what is getting collected, all that, those are different issues. But at that time, I will just tell you, okay, execute this procedure inside this package and pass this argument. At that time, we should know how to execute a procedure inside a package and how to pass the information. Okay, so that time I will tell you something like this. Run this command, exec dbms underscore stats dot gather schema underscore stats, and then within the parentheses I will say HR maybe. Okay, it will do something on the HR schema. Now you know what a schema is. You know HR is the name of the schema, and it will gather the statistics, which means what is a topic of total different discussion. It will gather the statistics on each and every object in the schema HR. And what is the purpose of collecting statistics? What is the purpose of gathering statistics is a different discussion. But that is something that we're going to do, and that's why it is important for us to know that yes, this is a package, this is a procedure inside that package, this is a information, the argument that we are sending to that package, and package will get executed because of my exec. So these packages here, anything that starts with a DBMS, they are called as built-in packages. Built-in packages. And our programmers will write their own user-defined packages. So that is the difference between a built-in package and a user-defined package. And now the last topic of the programming side is the trigger. So we have seen what a procedure is. We have seen what a package is. Procedure and function is one and the same thing. I'm not going to go into the details of what is the difference between a procedure and a function. It's a different discussion. But for all practical purposes, from our DBA angle, think of procedure and a function as a PL/SQL program. And then what is a package? Package is basically a collection of whole bunch of procedures and functions together. That is a package. Now the last thing in the PL/SQL programming is the trigger. Anybody who is doing the PL/SQL programming class, they will be spending their entire class in understanding what a package is, what a function is, what a procedure is. Their entire class is on that only. Our goal is just to go through a limited thing. What is a trigger now? Trigger is also a PL/SQL program. A procedure is a PL/SQL program, a function is a PL/SQL program, and trigger is also a PL/SQL program. But this program cannot be executed like this. EXEC, and the name of the program is let us say proc1 or trig1, TRIG1. If I create a trigger with the name trig1, I cannot execute a trigger program like this. Why is that? Because trigger is a special program. It is attached to a specific object. What are the objects? Tables. Table is one of the main objects. So a trigger is a program which is attached to a specific table, and that program, that trigger will get executed when a specific action happens on that table. And what is that specific action? An insert or an update or a delete. So if somebody, not you, anybody who has access to that table's insertion, inserts a row into that table, and let us say you had already created a trigger program for that table, and that trigger program is not just created for that table, so it is created for a table and on a specific action. Action is the insert or update or delete. Okay, so somebody has created an insert program for a table employee. So that is my trigger. And therefore that program is created, that trigger is created, already kept aside, and now some other guy comes in and inserts 2 rows into that table using the insert command. The moment he inserts the first row, my program will automatically get executed. My trigger will automatically get executed. I don't need to type anything like this. In fact, you cannot type an execute command for the trigger. So the insert statement on that table will fire that trigger. And the second insert statement will fire that trigger one more time. If 1000 rows are inserted into that table using the 1000 insert statements, like maybe our looping thing, then the trigger on that table will get fired 1000 times. That is what a trigger is. So trigger is a PLSQL program that will get automatically executed when a specific action happens on that table on which the table is created. The trigger is always created on a table. It cannot hang independently on its own. Tomorrow if you drop a table, all the triggers that are there on that table are automatically dropped. All the triggers on that table are automatically dropped. So that's what a trigger is. Now trigger is created on the table, that is fine. The trigger can also be created on a database. Trigger can also be created on a database. And what is the action for the database? Can database have an insert or update or delete? No, it doesn't make any sense to have an insert or update or delete on a database. Insert, update, deletes are only for the table. So then what are the actions on the database? The actions on the database are startup, shutdown. Okay, so there could be different type of an object and different type of an action that happens with that object, and then you can attach that trigger program to that specific action. So I write a program to send an email, a PLSQL program to send an email. And where do I attach that program, or where do I put that trigger on? I put that trigger on the startup of the database focus 1. Startup of the database focus 1, and suddenly when somebody starts up a database called as focus 1 database, the email is sent to the concerned person. Whenever a database is shut down, then email is sent, or whatever you do it. So trigger is a PLSQL program which gets fired when a specific action on a specific object happens. That is what a trigger is. And we'll talk a little bit about trigger. We are not going to write any triggers. Very rarely we will write a database trigger like a startup and shutdown. We will, as a DBA, we will never ever write a trigger on a table. That is done usually by the developers. We will write a database trigger maybe for a startup and shutdown, maybe to send an email and all that stuff. So that is what a trigger is. Just remember that part of a trigger. So that's kind of today's discussion about programming. What is a procedure, what is a function, what is a package, and what is a trigger. I will show you the code of a trigger maybe in administration too, on a database kind of a thing, but it is a PLSQL program. We will not be able to understand too much of it unless and until we have that programming background. Okay, any questions on the programming side of it? This is actually chapter number 6 and chapter number 7 from your book. Whatever we have discussed today so far is chapter number 6 and 7. And anything, if I have, there are certain things that I have not gone through, and the purpose of that is probably this is not the right time to go over those things, kind of, unless and until we have a lot of programming background, the PLSQL compilation options and all that configuration, not very frequently used by the DBAs also, but whatever we need to know, I have covered that much. So Bolo, any questions?
You said the syntax of procedure and functions are more likely same.
They are almost the same, almost.
Then what's the difference?
Then what's the difference? Okay, the basic difference I will tell you. Functions are used in select statements. Let us say there is a function. You have used a function called as upper. Upper is a function to convert a data from lowercase to uppercase. And how is data getting converted from lower to upper? Like this. You type something like this. Select upper, and maybe you type lowercase shaker from dual, or instead of typing dual you may say employee, and here instead of shaker you may pass the name of the employee, the column name. So what will happen, the shaker will get converted into uppercase and you will see SHEKHAR in uppercase there. So this is a function, this is not a procedure, and because it is a function it can be used in a select statement. Because it is a function, it can be used in a select statement. If it was a procedure, you cannot use that in a select statement. These are certain differences and restrictions on each other. That is what PLSQL, that is how PLSQL has been designed. So one of the fundamental differences is functions can be called from the insert, update, delete, select statements, but the procedures cannot be called. Like for example, our proc1, no, this cannot be done because it was a procedure. To execute a procedure, you have to always type exec and the procedure name. You have to execute a function, you have to put that in the select clause or update clause or delete clause. That is
Procedure is for just create thing.
no, it is procedure is for executing exec and the name of the procedure.
That's more likely a script.
It's a script. You can think of it as a script or a program which is going to be executed when you type exec and the name of the program. This program, whatever is written inside the upper program, there is also the program, it's a PLSQL program that will be executed when you call it like this. So calling the procedure and calling the function is a different way.
It means we can use function in a procedure.
You can use function inside a procedure. Yes, you can do that. Yes.
That means first in the first program, I would select statement right in that program.
Yeah, you can write a select statement inside a PLSQL program. Whatever we saw between begin and end, that is what you are asking, you know? Whatever we see between begin and end, you can write an insert statement, delete statement, select statement, all those things. All that is possible.
So if there are two databases on different OS, can they be linked by DB-link?
Yes, they can be. In fact, that is the purpose of a DB link. Okay, DB link's purpose is now what we'll just briefly discuss since you asked. This is a topic of our different discussion. This is one Unix machine. On this Unix machine, there is a database called as Focus1, and then this is a Windows machine. And on this there is a database called as Focus2. Okay, there is a schema here called as A, there is a schema here called as maybe B. Now if user is logged into this schema, can he select a table, can he select data from a table which is over here? The answer is yes, he can do that if he has created a tunnel called as DB link. If he wants to access data from another schema in the same database, can he do that? Yes, he can do that. There is no requirement for the DB link. All he has to do is say c.table name. So, fundamental difference. If you want to select from a table which is in your own database but a different schema, just say schema name dot table name. But if you want to select from a table which is in a different schema and a different database and maybe on a different machine or maybe on the same machine, I don't care, then you have to use a DB link, and we will see how the DB link works a little later, but this is how you do it. Let us say the name of the table is K here and I am logged in as B. I would say select star from K is here and the @ sign, and the name of the DB link is, let us say, DBL1. The DB link also has a name, so DBL1, that is what you would say, and a semicolon. You are logged in here, but you are now looking at the data in a different schema in a different database. I don't care whether it's on a different machine or not.
We don't need to provide the database.
We don't need to provide the database. It is provided already when a DB link is created. DB link create has a specific command, create database link and all that stuff. So I think tomorrow we will discuss more about DB link, and we will go through that option also, like how the DB link is created. Now we know the concept of a schema and a database and all that stuff. Okay, anything else? Okay, then we'll stop here.